Okay? This is just some review stuff right here. All right. Okay. Okay, everybody paying attention? All right. A horizontal line has a slope of 0 and an equation that looks like y equals any number that you want to put there. Y equals 2, y equals 7. Just y equals a number. A vertical line has a slope of undefined. You mean those notes? Quiz is on. Yeah, I don't have them right now. I'll have to get in a second. Okay, an equation that looks like x equals a number. A slanted line has a graph of y equals mx plus b, where m equals slope and b equals y intercept. And to graph a line, you must solve the equation for y, plot the y-intercept, then use the slope to find the next point on the graph. So whenever you get done with your quiz, you are going to graph these 10 lines right here. This is sort of like a little bit of a review. You should be good at it because it's very similar to the inequalities that we've been doing. Right? This is just a little bit of a review that you're going to work on. And then once everybody is done with the quiz, we're going to pick up looking at systems of equations, which is going to be the next part there. So this is just a little bit of review that you're going to do, number 1 through 10 on that once you finish your quiz. Okay, any questions? All right, your quiz is on Delta Math. You may use the whiteboards if you would like. You do not have to turn in your work. I am going to turn on ClassWise and lock you to Delta Math. So go ahead and log into Delta Math. I think if I lock you before you get there, it doesn't work. So go ahead and go to Delta Math. It is quiz 416. You may begin whenever you get there. Pair that makes both equations true. All right, so here's an example question. Find the solution to the following systems of equations. We got y equals 3x minus 4 and y equals x plus 6. So without any of the methods that I'm going to show you, you would have to guess and check this. So like, for example, like let's say I plug in 0 for my x right here. So y would equal 3 times 0 minus 4. That would be y equals 0 minus 4. So y equals negative 4. So that would be the point. 0 is the x that I plugged in. Negative 4 is the y that I plugged in. So this point is on this graph. Y equals 3x minus 4. I really should have known that because of my y-intercept, right? But if I plug it into the second equation, if I do negative 4 equals 0 plus 6, is that true? No. So it works for this equation, but it doesn't work for this one. So then I'd have to go back, well, that didn't work. Maybe I could think of another one that would work. So you guys start thinking. See if you can figure it out without knowing how to do this yet. I'll work through some up here. So like, if I plugged in 2, 3 times 2 minus 4 would give me 6 minus 4, so I get 2. So the point 2, 2, if I try it, right? 2 equals 3 times 2 minus 4, so 2 equals 6 minus 4. That is correct. That is on this first line. So that works for that one. If I try the second one, I got 2 equals 2 plus 6. Is that true? No. So that's not it. Are you starting to see like the difficulty? Anybody found it? Anybody found one that works for both? 5. 5 for x. So if I do 5 for x, all right, 5, 11. Okay, so if I plug that in to the first one, I'll have 11 equals 3 times 5 minus 4. So 11 equals 15 minus 4. Is that correct? Yes. All right, and then if I do 11 equals 5 plus 6, is that correct? Yes. So that is the solution. 511. But guessing and checking, we were lucky that Aiden came up with that for us. Guessing and checking is really difficult to do with this. Like trying to find something that makes both of these true is really difficult to do. So what we'll be learning in Unit 5 is lots of different ways that we can use systems of equations, or use a lot of different methods for solving systems of equations. All right. Today, the way that we're going to do that is we're going to do this by graphing. So to do this, we're going to graph both of the equations and find their intersection. Okay, the intersection is the place where they cross, right? So if I do that for this problem that I just did, if I graph that first line, I've got y equals 3x minus 4, so I've got y-intercept at negative 4, and the slope of 3. So I'll draw in this line here. And if I'm going to use a different color. For the second one, it's y equals x plus 6. So 1, 2, 3, 4, 5, 6. And we got a slope of 1. 1, 2, 3, 4. This one goes off the graph just a little bit. But they are going to cross right here. And that point is the point that Aiden told us about. It's 511. Yes. You are a day ahead of us. So, yes, but we're not going to do that today. Yeah, that's a different method. Today we're just going to graph. All right, so, and sometimes that is easier, Aiden, like on number 1 you could do that, and it would be pretty easy. Number 2, it's actually easier just to graph that one by hand than to set them equal, because you got to deal with those fractions and dividing fractions if you do it. So just depending on what you're given, sometimes that is the best method to use, and sometimes graphing may be easier. But for right now, we're just going to graph. So if we are looking for the solution to a system of equations, we're just going to graph the two lines, right? And you guys already know how to graph lines, so hopefully you should be good at that. So if I've got y equals 9, what type of line is it? Is it vertical or is it horizontal? Horizontal. Right here at 9. Let me use a different color for the other line. The other line has a y-intercept at 1, 2, 3, 4, 5. And then we're going to graph this here. Alright, and that intersection, that point where they cross, what are the coordinates of that point? I think it's 4, 9. Yeah. The x-axis 1, 2, 3, 4.
What happened to 5? What happened to 2x?
Oh, that's why. That's why you're getting 2, 9, because I graphed it wrong. I graphed it just as a slope of 1, so I'll make that go away. Alright, let's try that again. You're probably right about that 2, 9. 1, 2, 3, 4, 5. Slope of 2 up 2 over 1. Oh, yeah. Alright, so that point right there is 2, 9. And so you don't have to do this on every problem, but let me just show you, like if you take 2, 9, if you plug it into this equation, you got 9 equals 2 times 2 plus 5, which is 9 equals 4 plus 5. Is that correct? Is that true? Yes. Over here, you got y equals 9, so when you plug it in, you would just have 9 equals 9. Is that true? Yes. So it is on both lines, so that is the solution there. Okay, let's do the next one here. And I may let you go. All right, so we got y equals 5/3 x plus 3, so 1, 2, 3. And then 5/3 up 1, 2, 3, 4, 5 over 1, 2, 3. And it's important on these that you draw the line out all the way to the edges of the graph. And then we've got our second line. Has a y-intercept at -3 and a slope of 1/3. If I graphed it wrong, or
That happened to me too.
Is it
I didn't find the point second A.
alright, let's see here. Let's see. Y-intercept at 3 up 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. Yeah, I've graphed it correctly. Alright, so here is, I probably put this here on purpose, I think. Here is a major drawback of graphing. Right? I've graphed this, I've graphed it beautifully. Can you tell what the answer is? It didn't hit on grid lines, right? It didn't hit where they cross perfectly on grid lines. So I know that that answer is like close to -5, -6 sort of. It's like it's in that general area. But -5, -6 is not my answer. So this is one of the limitations to graphing. It's going to be difficult to actually solve this with graphing. I think, I'm not looking at my, let me look at my key. I think that's the only one I did that on. Let me check. Let's see. I've graphed something. Oh, I do have this graph wrong, but it's still a bad problem. I put my y-intercept at -4. It still doesn't make a difference, though. It's still a bad question, but it's easier to guess. I mean, it's not a bad question. I'm pretty sure I put this here on purpose. All right, so now I have it graphed correctly. So whenever we look at this, where does it look like that point is at? What would be your guess? I think it is not on the grid lines. So it's a little past -4. So, okay. And then what about my y coordinate? Also, I think probably 4.5. And I'm going to put a question mark here next to it right now because I'm not sure about that, right? So how could I check to see? If I plug it in, so if I do -4.5 equals 5/3 times -4.5 plus 3, and yeah, I'd either have to get a decimal here if I could use the calculator, or -4.5 is -4 1/2. What is that as a mixed number? Oh, not a mixed number, improper fraction. -9/2. Let's use that instead. So -9/2 would equal, this will be -45/6 plus 3. If we get common denominators here, it's -45/6 plus 18/6. That is going to be, let's see, 27, -27/6, which if you divide by 3 will give you -9/2. So it works for that one. This is not very easy, right? I'm going to show you a better way eventually. If we do this here, -9/2 would equal 1/3 times -9/2 minus 3. So -9/2 would equal -9/6 minus 3. Get common denominators by multiplying by 6 on top and bottom. So -9/2 would equal -9/6 minus 18/6. That's going to give you -27/6, which does also reduce down to 9/2. So that is correct. So it is for -4.5, -4.5. But that took a while. And if it had not been 4.5, if it had been like 4.62, it would have been really hard to do that, right? To guess that correctly. So graphing has its limitations. Also, if I want to graph these on Desmos, if Desmos is allowed, which it is not right now, but if Desmos was allowed, if you graph this on Desmos, it's going to show you the intersection. So that is another option if Desmos is allowed. But right now I don't want it to be allowed because I want us to practice doing these by hand. A lot of times these will show up on the calculator inactive. So you guys have 6 more problems here. I want you guys to graph these and, oh wait, let's see. We need to do a couple things. All right, let's do number 6. We're going to do number 6. Yeah, number 6 will do. All right, let's see what happens for number 6. All right, I've got y equals -2x plus 2. I can graph that right away. So y-intercept at 2, slope of -2. that will be this graph. And then I've got 2x plus y equals negative 2. So to graph that, I'm going to have to solve for y. I'll subtract my 2x. So y equals negative 2 minus 2x. If you remember something about parallel and perpendicular lines, what could you tell me? These two lines have the same slope. So when I graph these two lines, they are going to be parallel. Not a parallelogram. Just parallel lines. So where do they cross? Nowhere. The solution to a system of equations is the place where they cross. These don't cross, so we would say this one is a no solution.
No solution, or can you plug in the
No. You can't plug in 0. It's just no solution. Because the answer would have to be the coordinates of the point where they cross, and these do not cross. So it would have to be no solution. I don't think you're going to see it happen on these problems on the notes, but let's make a note right here. If the two lines are the same line, we would call that infinitely many solutions. I don't think it happens on these problems, but we'll probably see it somewhere to come. So if you solve them both for y and they end up being the exact same line, then it would be infinitely many solutions. Because if you have one line and the other line's the same, where do they touch? Everywhere, right? Everywhere on those lines. So it'd be infinitely many solutions. All right, so these last 6 right here are going to, I want you to finish them either before you leave or as homework. You got about 15 minutes, so you might be able to do it before you go. It is your homework if you don't finish it.